In many regions across the world, ancient rivers that once carved through mineral-rich mountains left behind more than just ordinary sediment. One of the most overlooked ways to find gold today is inside river stones that most people pass by without a second glance. These rocks, which often appear plain and worthless, can sometimes contain tiny gold nuggets embedded in cracks or clinging to their surface. The key lies in recognizing subtle visual and textural clues that separate an ordinary stone from one that holds hidden value. In areas with a volcanic history or a high presence of quartz and silica-based minerals, gold was often deposited through hydrothermal activity. Over time, as rivers eroded these rock formations, small fragments of gold broke off and traveled downstream. These fragments tended to settle in specific zones, behind large rocks, in sharp river bends, or within deep crevices in the riverbed. But unlike the dramatic gold flakes seen in media, these deposits are rarely visible to the naked eye. In many cases, they get trapped inside medium-sized stones, especially those with rough textures, oxidized patches, or faint white veins running through them. Quartz is one of the most reliable indicators. While not all quartz holds gold, white, or milky quartz with dark streaks or metallic stains, particularly reddish-brown ones, often indicates the presence of sulfides, which commonly occur near gold. It's important not to break the stone open right away. Instead, using a strong light or magnifying lens, examine the surface for tiny reflective spots or streaks that shine differently from the surrounding material. These visual cues, along with an unusually heavy weight for the stone size or an oily texture, are strong signs that gold may be present. Another important clue is how gold settles in relation to water. Being extremely dense, gold naturally drops to the lowest points in a stream. Over time, the weight and pressure of flowing water cause small gold nuggets to become lodged in the bottoms of flat stones, particularly those with natural cuts or ridges. Many experienced prospectors advise flipping over stones in calm sections of the river to check for black sand, a heavy, dark material composed mostly of magnetite and hematite. Black sand often accompanies gold and can indicate that the surrounding rocks are worth examining. Color can also be a subtle but useful indicator. While pure gold has a distinctive glow, in its natural form it may appear dull yellow or even greenish if mixed with silver. When stuck to a stone, gold may look like a simple golden stain. A basic scratch test, lightly scraping the spot with a metal tool, can help. If the shine remains after scraping and doesn't turn to dust like iron pyrite or surface rust, it's likely real gold. This streak test is a common method used by traditional gold hunters to confirm gold presence without damaging the specimen. Geographic context plays a vital role. In many parts of the Americas, especially in mountainous regions with colonial mining history, dry riverbeds or old abandoned river channels are prime locations for finding gold-bearing stones. The best conditions include exposed bedrock, tightly packed gravel deposits, and remnants of old sluices or dig sites. Often, the gold left behind by early miners still sits inside rocks that weren't processed due to lack of technology or because they didn't show obvious signs of value at the time. The most important trait for success in this search is patience. Rather than collecting every stone that looks interesting, it's better to identify patterns. If several rocks in the same area have metallic veins, feel heavier than expected, or show signs of oxidation, that zone deserves closer inspection. Mark the area, take multiple samples, and analyze them carefully. Even with simple tools like a magnifying glass, a magnet, and a gold pan, a basic field test can yield accurate insights. The real skill lies in training the eye to recognize what others overlook, and in the willingness to look twice at stones most people would ignore. Once an individual begins to develop the ability to distinguish potential gold-bearing stones From ordinary river rocks, the process of field analysis becomes far more efficient. But there's another layer to identifying gold in natural settings that many overlook: environmental context and geological layering. Gold does not appear randomly. It follows specific patterns driven by erosion, gravity, water flow, and mineral associations. To truly maximize the chances of discovering nuggets embedded in river stones, it is critical to understand the terrain story, how the land shifted, where water once flowed, and what minerals tend to coexist with gold deposits. One of the strongest indicators of gold presence is the existence of what geologists call ancient river channels. These are dry or diverted pathways where rivers used to run, often centuries ago. Because gold is extremely heavy, it tends to accumulate in these historical beds. When modern prospectors search for gold, they often overlook these dry gravel terraces in favor of visible water. Yet, many of the most valuable stones, including those containing gold, can be found nestled in compacted layers of rock and sediment where water hasn't flowed for decades. These layers are typically marked by compressed gravel, reddish or orange oxidized zones, and the occasional appearance of tightly packed clay. Such environments tend to preserve gold more effectively than open riverbeds. Another key concept is mineral association. Gold rarely travels alone. It often coexists with minerals such as iron oxides, magnetite, quartz, and sulfides like pyrite and arsenopyrite. Observing stones that contain multiple colors, white quartz, black magnetic inclusions, and reddish iron staining, is often more useful than looking for golden rocks. Most natural gold in stones is invisible at first glance, but the environment gives it away. When magnetite grains appear in clusters, when the stone seems to bleed rust when exposed to moisture, or when a weak sulfur-like smell is present. During a scratch test, these are strong clues. The more diverse the mineralization in a single rock, the higher the probability that microscopic or hidden gold is locked within. The physical structure of the stone also plays a crucial role. While gold-bearing rocks can come in many shapes, those with cavities, fractures, or small hollow channels tend to be more promising. That's because water flow in rivers causes gold particles to lodge into crevices. In time, other minerals may seal over these gaps, creating the illusion of a solid stone. When broken open carefully or studied under magnification, these rocks often reveal thin streaks of metallic luster, not just on the surface, but deep inside. Such structures are common in conglomerate rocks or heavily eroded quartz stones that have traveled a long distance through abrasive environments in field conditions. Many prospectors use simple techniques to test stones without damaging them. One of the most effective is the use of UV or shortwave light to reveal mineral reactions. While gold itself does not fluoresce, certain minerals associated with it do. A stone that glows under UV light, especially with blue, yellow, or green hues, may contain minerals such as scheelite or calcite, which are often found near gold. Although this method isn't conclusive on its own, it narrows down which stones are worth examining more closely. Another field method involves the use of portable digital scales. Gold-bearing stones are often denser than they appear. If a small rock feels unexpectedly heavy for its size and has even one visual indicator, such as oxidation, quartz veins, or magnetic response, it should be tested further. Cultural knowledge also plays a part in successful identification. In regions like Mexico, Peru, or Colombia, indigenous communities and rural prospectors have long relied on visual and tactile clues passed down through generations. They don't need expensive tools. They rely on intuition built through years of exposure. For example, they know that after heavy rainfall, stones along certain curves of a dry riverbed are more likely to contain mineral fragments. They also understand that flat, rounded stones collected downstream of quartz-heavy cliffs often act as natural gold traps. Observing where local searchers focus their attention, and more importantly, where they avoid, can reveal patterns invisible to outsiders. As understanding deepens, what once seemed like chance becomes a guided process. By combining visual inspection, environmental awareness, simple field tools, and local insight, the process of identifying valuable stones becomes less about luck and more about observation. And when the focus is gold, that shift from guesswork to pattern recognition is the difference between leaving empty-handed and discovering a stone that quietly holds a fortune. Gold doesn't announce itself loudly. It waits silently inside stones that millions walk past until someone learns how to truly see. Once a gold-bearing stone has been identified with reasonable certainty, the next phase is proper handling, documentation, and, if necessary, verification. This is where many beginners make critical mistakes that can reduce the value of a find or compromise the accuracy of its origin. A common misconception is that all gold must be extracted immediately. In reality, some stones hold more value intact than broken apart. Museums, collectors, and geological institutions often place greater interest on natural specimens that preserve their original form, especially when the gold is visibly embedded within quartz or surrounded by natural mineral structures. 4. Those hoping to profit not just from the metal, but from the uniqueness of the find. Preservation is essential. The first step after discovering a potentially valuable stone is to clean it, but gently, using only water and a soft brush. Any dirt or organic residue should be removed without scratching the surface. Chemical cleaners or abrasive tools must be avoided, as they can damage or alter the mineral composition. After cleaning, the stone should be photographed under various lighting conditions and angles. This isn't just for documentation. It allows the prospector to later observe details that may have been missed in the field. High-resolution images can also be shared with geologists or mineral appraisers for expert input before any decision to sell, display, or study further is made. Storing gold-bearing stones properly is another overlooked detail. Moisture and air can cause oxidation in minerals that coexist with gold, which may change the appearance or even weaken the structure over time. A small airtight container, lined with soft padding and kept at a stable temperature, is ideal. Some use silica gel packets to reduce humidity. If the stone is particularly fragile or visibly includes sulfides, a light mineral oil coating can sometimes be applied to preserve the surface, but only if advised by a mineral specialist. Those seeking to confirm the presence of gold without destroying the stone have several options. Non-invasive testing methods include handheld XR analyzers, X-ray fluorescence, which can detect gold and associated metals within a sample by analyzing its atomic composition. While such tools are expensive, some universities or laboratories offer testing services at low cost for independent prospectors. Another option is specific gravity testing, a method that calculates the density of a stone to estimate the presence of heavy metals. Though not as precise, it's a helpful tool for field verification when used alongside visual clues. When a stone is confirmed to hold gold, the next decision is what to do with it. For many, especially those finding their first nugget or mineralized sample, the discovery holds sentimental or educational value. Others may choose to sell, either as raw material or as a collector's item. In this case, understanding the market is important. Jewelry buyers usually offer payment based on refined gold weight, often underestimating the specimen's full value. In contrast, mineral collectors or museum curators might pay significantly more for a visually striking piece, especially if it includes unique mineral formations, historical context, or documented origin. That's why proper record keeping from the moment of discovery, including GPS coordinates, date, river name, and geological context, can greatly increase the credibility and appeal of the find. The true power of this process, however, lies not just in extracting gold, but in changing how we observe the natural world. What begins as a stone overlooked by thousands can, with knowledge and patience, become a window into Earth's geological memory. It connects us to processes that unfolded over millions of years: heat, pressure, erosion, and chemical transformation, all coming together in one object held in the palm of a hand. This shift in perception transforms casual walking into a trained search, and every riverbank into a landscape full of possibility. Even more importantly, this knowledge, once acquired, is portable and timeless. Whether along rivers in North America, volcanic zones in South America, or sedimentary valleys in Europe, the clues remain the same. Gold's density, mineral associations, weight, and context follow consistent geological principles. Those who invest in understanding them carry a skill that few possess. In an age where digital wealth dominates attention, the ability to read the land and recognize the physical presence of real, hidden value becomes not just a rare gift, but a quiet rebellion. A return to listening to the earth by mastering how to identify gold in river stones, even those that seem completely ordinary. We not only open the door to financial potential, but also to a deeper appreciation of the planet's silent, hidden layers. What others miss in haste or ignorance becomes visible to the patient and informed. And with each stone discovered, cleaned, and understood, we honor the ancient landscapes beneath our feet and the enduring treasures they still hold.